Hello students, today I am going to deal with aldol condensation. This is one of the most important name reaction that is asked always in exams. Let's see what is this aldol condensation is all about. Basically, aldehydes having alpha hydrogen undergo self-condensation on warming with dilute or mild base to give beta hydroxyaldehyde called as aldol. Reagents used for this is dilute NaOH or alkali metal alkoxides or aqueous alkali carbonates. Here I am taking one example. For example, CH3CHO when treated with CH3CHO, that is ethanol. So 2 moles of ethanol are being treated over here in basic medium, and this forms CH3CHOH CH2CHO. This is the aldol also obtained, and this when further heated is dehydrated to form alpha beta unsaturated aldehyde. Now let's see the mechanism behind this. The first step involves formation of resonance stabilized enolate anion by removal of an alpha hydrogen from aldehyde. The second step involves the attack of enolate anion with the carbonyl carbon of the second molecule of aldehydes to form alkoxide ion. And the third mechanism involves the alkoxide ion that takes up a proton from the solvent to yield aldol. Actually, the reactions between two ketone is not very successful. This is because the carbonyl carbon of ketone is less positive due to plus I effect and more sterically hindered relative to aldehyde. Let's see the mechanism, how it operates. The mechanism process in the first step, if you see CH3CHO, where OH minus is coming from the solvent, and this breaks down the H plus from the aldehyde forming a water, and enolate anion is obtained. Okay, the enolate anion in the second step treats with the second molecule of ethanol to form an alkoxide ion. This alkoxide ion rearrange itself, which is beta hydroxyaldehyde or aldol. And in the third step, the beta hydroxyaldehyde when heated undergoes elimination reaction to form alpha beta unsaturated aldehyde. So it's a very straightforward reaction. If you see here, the mechanism involves the movement of electron. So most important thing is how you obtain the movement. Here the double bond O, which is more electronegative, asks the electron from carbon, and in return this carbon asks the electron from the another carbon that is placed just right close to it. So it forms CH2 minus, that means the carbon is giving its electron, and here ultimately the oxygen of the double bond O breaks, and this O takes the electron over here forming the enolate anion. This enolate anion further acts with the another aldehyde in such a way that the carbon here again forms the positive carbon, and oxygen here takes the electron from this. As a result, positive carbon adds up with the negative carbon, and this forms a bond between both, forming the alkoxide ion. The alkoxide ion further forms beta hydroxyaldehyde by taking the proton from the solvent and thus forming the OH over here. And further, this when heated liberates out hydrogen and hydroxyl from one of the carbon placed close to it. So OH moves from this carbon and H moves out from this carbon, ultimately forming a double bond between both, and this forms an alpha beta unsaturated aldehyde.